What up YouTube, TK here. Today we are back with scooters because yes, this is the Razor E300 and yes, it's a lot of fun, but this isn't where the story began. No, I'm going to take you back to where my scooter escapades all really began, and we're going to talk a little bit about where we're going to go from there. Let's go. So this may look like a bastardized push scooter, and that's because it's precisely what it is. Basically, back 10 years ago when I started building scooters, didn't have the money for a big time electric scooter off the shelf, so I thought I'd build one instead. So I started with a nice steel framed Razor scooter here, which we can see in green, and then I basically hacked it to pieces, as you tend to do. This is literally the second electric scooter I ever built because the first one ended up in the bin. It's a steel frame Razor that I converted to electric power, and you may be wondering why there is no motor or batteries or anything electronic in it at all, and I'll be happy to answer all those questions shortly. So I'm going to give you a tour of what happened here, what we did and why, and then I'm going to get into what's coming next, because yes, that is correct, we're going to be doing something pretty damn exciting with this one, and I cannot wait to see how that turns out. Let's go. So we'll start by looking at the bones of the thing, and yes, this is a basic push scooter from the early 2000s that is, albeit, heavily modified. It's from the Blade brand, which was popular in Australia in the early 2000s. They mostly sold them at Kmart and Big W, I believe. What makes this one different to most push scooters out there at the time is that this one actually has a steel frame. It felt quite deluxe, having something that none of the other kids did back then. I actually picked this up back in something like 2002 with some money that a distant relative gave me, and I had a lot of good times, rode it around, did a bunch with it. Originally it came on 100mm wheels, and originally they were about here on the frame. It folded just like any other push scooter, and there wasn't a whole lot to it. Now, the first electric scooter I ever built was built around a brand new Razor aluminium frame push scooter, and that had some problems. It was difficult to work with, and going into the second design, I thought it would be cooler and easier to make modifications if I had a steel frame because I could just weld to it. Yes, it would be heavier, but that was something I was willing to take. So now obviously its appearance is quite different from stock. There were some significant changes made during the electrification process. Number one of which is this entire back frame here. Now this is welded up out of old fence post. My grandfather helped me do that with his MIG welder because back then I was not a welder. Initially this was just done to create a platform for the battery pack and the motor. However, then also became apparent that this would allow the wheel to be moved back further, giving a more stable platform at higher speeds. So that was pretty good. You can actually see we have these outriggers here, which were the motor mounts, quite crudely drilled. Everything on this was done with hand tools. There were no lathes or mills or anything advanced used in the build, which made things difficult. The modified steel frame was then augmented with these aluminium sections. These are just offcuts that were found from around the place, already pre-bent. That gave a nice flat surface for mounting various pieces of electronics, batteries, motors, and so on and so forth. If you're wondering where all that equipment is, it all ended up in the bin long ago after the 17th or 25th time that this thing blew up, but we'll get to that later. You see the aluminium offcuts also form a foot plate here because this scooter actually originally came with a plastic one. I thought it'd be cooler to go with aluminium and then realized that my offcuts weren't wide enough, so we ended up fitting a half of a skateboard. Doesn't look particularly good, but does make it very easy to ride, so, you know, swings and roundabouts. Now the next major modification we'll see is at the front here, which is this front wheel which has been lowered. Now let me zoom in there and explain what's going on. So at the front here we have these plates welded to the front stem, and the purpose of those was to replace the original mounting plate for the front wheel. The original mounting plate for the front wheel finished about here and mounted a 100mm wheel. What happened is when I was driving this around in the early days, I eventually one day melted the rear wheel. I literally had been riding around for 20 minutes, top speed, and I was going round and roundabout, and the back of the scooter just slid out from under me, and when I lifted it off the road, I noticed that the rear wheel was completely mangled and melted and bent and just gone. The idea was then to replace those small tiny 100mm wheels, which really couldn't take the punishment, with something a bit bigger that would handle higher speeds and also be easy to work on. To do that, I had to create a drop mount at the front to fit the bigger wheel. Now this is just some basic steel plate. I believe it's cut out of a fence post. And these welds were actually done with the same gasless MIG welder that was done at the back. However, I did these myself. These are the first production welds I ever did. They may actually remain the only ones thus far. And if we get ever closer, we can see where the original plates were cut off and had the larger ones welded on. The mounting point was then just drilled through with a power drill. So that's how we got the bigger wheel on the front, but let's take a look at how we handle things at the back and how we actually made this thing an electric scooter. So at the back of the scooter here, looking down from the top, we have this L section, and this is where the batteries were mounted. We had a 4-cell lithium here and a 4-cell lithium here, and that gave us a total of 8 cells, around 30 volts nominal, whatever it is. And that was the power source for the scooter. So this was a huge improvement from my first build, which used lead acid batteries. They were very heavy, and on a scooter that, like this one, also had solid wheels, they didn't deal with the vibration very well and were continually breaking. Like internally, literally, the links in between the cells would break, meaning I had no power. Lithium power was an excellent upgrade. To charge it, I actually hardwired all the cells to a DB15 connector, which sat on a overplate that went over the top here, folding over the top, protecting the batteries from the elements, and they were all packed in with foam similar to the Razor E300 mods that you've seen me do. Lithium power was just an absolute revelation. I had much more range, much more speed, and I was very, very happy compared to my previous build. So the batteries formed the power supply, and I then had a 350 watt 24 volt motor mounted here. Obviously we were running it slightly overvolted, which gave us a bit more speed. That connected to the wheel with a chain with this cog here, and we'll take a closer look at that later. The motor was just a DC brush type, very, very similar, if not identical to what you actually get in a stock Razor E300. However, my build was a lot faster due to a combination of gearing and the fact that we were overvolting the motor. So to run the brush motor, I decided to build my own speed controller out of a PIC 16F 873 something or other. Now, this is where I started getting into some weird design choices that you would typically never see by someone a little more experienced. I had the speed controller mounted all the way up here, or at least most of it. I had a control box with the PIC microcontroller up here with a potentiometer on the case for a throttle, and that was powered by 2 power lines that ran all the way back to the batteries, picking up off, I think, the first 2 cells, and they were then run through a 7805 regulator to supply 5 volts. However, this was a 350 watt motor, you know, we're talking quite high current here. I needed a MOSFET to switch the motor. I didn't want that to be a long way away because that would mean I'd have long high current lines, and that's quite messy. So I decided to mount the TO3 MOSFET, real old school, on the back of the aluminium here on the case, and that acted as a heatsink, and it looked really cool having an old TO3 on the back. But what that meant was that the signal line that was switching that MOSFET came all the way back to the handlebars. Now, anyone that knows anything is going to say you don't want to be running a 5 kilohertz PWM signal down 1.5 meters of thin wire. It can be done, it's just not generally the way you build a brush motor speed control, but regardless, I did it. It worked for a time. However, I then blew the TO3, and then I blew another TO3, and then I'd run out. So I had to specify a new FET. TO3s weren't around anymore, neither were the old designs, so I got a TO220, brand new, high power FET. The problem I had was that these would blow almost immediately. I suspect, though can't prove, that the higher switching speed of the newer FETs meant that the back EMF was higher and I wasn't properly snubbing the circuit. And that's why they kept dying almost immediately. There were also weird power supply issues with the PIC, and after that the scooter basically never ran for more than 10 minutes at a time. I would just blow FETs like nobody's business. I consulted some experienced engineers who pointed out that I should probably be using a gate driver and I shouldn't be using such long cable lines. But by that point, the time and money that I had to spend on the project had largely evaporated. So what ended up happening was this got shelved for a later date, back in probably late 2012, and the motor came off and the batteries came off and they sat in a separate cabinet, and they've since gone missing, and all I'm left with is this shell. So let's just look a little bit more closely at the drivetrain. So here we have the components of the rear drivetrain. We have the axle, we have the chain, which is completely rusted, and that is T8F chain, just like the Razor E300. And we have the wheel. Now, there was quite a bit of engineering that went on here in order to fit an electric motor to a scooter that isn't designed for it, because it doesn't have a powered drivetrain, it doesn't have any way to mount motors, it doesn't have any way to hook up a chain, because it's just not meant to happen. So the way the scooter originally worked, it literally just had a 100mm wheel like this, but without any of these other bits, and that was just running on a simple shaft with a bearing inside, just like a skateboard wheel. Stock, this scooter, like all other push scooters of the era, had a simple wheel on a simple shaft with skateboard bearings, and that was it. To drive that, I thought rather than try and find some complicated way of fixing the wheel to a shaft, I would instead drive the wheel directly. So this cog, which we see here, was made for me by a local guy with a workshop. What he did was he grabbed a piece of steel about 3mm thick, cut it out of a fence post, cut it into an octagon, and then held that in a power drill and attacked it with a grinder. That was his lathe. He literally span this up in a power drill in the chuck and came at it with a grinder until it was round. At that point, he then printed off a drawing of the right size cog, generated in Inkscape, and then just hacked at it with the grinder, which is why you can see the gear teeth don't really have any formal profile as such. They're just little spikes. But the cog worked brilliantly. There was never any problem with it. In fact, it was so good at transferring power that, as I said before, it transferred too much power to the original wheel. What actually happened is this cog was bolted through the 5 spokes of the... What actually happened is this cog was mounted through the 5 spokes of the original 100mm wheel, not unlike this one here. So we had a bolt through each spoke going through to the cog. These same 5 holes you see on the cog now. And what happened was, that was fine. That locked the cog to the wheel, but the plastic spokes of the wheel started to shift relative to the outer rubber coating. And the plastic got hot and melted due to all the power going through it. And so eventually the entire wheel just became a hot glove of plastic with some rubber around the edge. Pretty frustrating, which is why we went to the bigger wheel. So I was worried about the same thing happening with the new wheel. Now when we got it, it looked just like this. The front one we just bolted straight onto our new mounts, but the rear one I wanted to do some work on. So we filled it with bog. This is just the kind of stuff you use to repair body panels on a car. Nice thick fiberglassy type material or whatever it is. And we filled it up and made a nice solid structure. We then drilled 5 holes with that. And keep in mind, these aren't drilled particularly accurately because we were only doing it with hand tools. And then bolted that through there and had a clamping plate on the rear to hold it all on. And to be honest, it came out pretty well, even though it looks remarkably off-center there. The wheel was strong and held up, and unfortunately the electronics would blow up long before the wheel would ever melt again, which was a sad thing. But for me, this wheel really felt like an engineering triumph, because this cog and this backing plate and this whole filling setup, this was all done in a home workshop with just hand tools, you know, just a power drill and a grinder. And the fact that it worked as well as it did was just, it felt really cool. And you can hear the bearings are getting a bit gritty now in their old age, but you know, that was that. The other problem I had at the rear, and I never actually fixed this, was the distance between the mounts at the rear was too wide, essentially. I obviously needed room to clear the chain drive, but it was just a bit too big of a span. And the problem is, this is designed for what I believe is an 8mm shaft, which when you're putting on your 70, 80 kilogram adult is not really enough. So having no machining ability and not wanting to get into the nonsense of swapping bearings and machining out the wheel further, I endeavored to just use what I had to hand. So I took another M8 bolt, and this one I actually filled with epoxy and then sanded down. I literally slathered epoxy on the threads and then put it in the drill, spun it up and sanded it back until it was smooth. And the reason I did this was because I felt like that 1/2 millimeter of thread, you know, was robbing me of significant strength. And if I just did that, filled it with epoxy, that would give it enough strength not to bend. And well, it's still kind of bent a little bit. But that was annoying rather than a showstopper. It never really killed the scooter per se. It just kind of, you know, it was something I wanted to fix in future. So overall, this scooter was a hell of a lot of fun to build and even more fun to ride. At its peak, when I had it running the best, I actually got this thing up to 38 kilometers an hour, which is pretty much on par with what I've done with the Razor E300. And this is actually why I bought the Razor, because after having so many issues building my own speed controller and doing all my own mechanical design, I wanted to sort of eliminate those as much as possible and just try to hack my way to something faster. In the end, I had a lot of fun with the Razor E300, but now what I'm keen to do is actually grab this thing, and this is going to be my new high-speed beast, because the Razor's great to get around on. It's got pneumatic tires and it's nice and comfortable and it's sturdy and robust. But I want to go nuts. I want to go crazy. I want to go 50 kilometers an hour, let's say. This is the platform to do it. It's got hard wheels, which are perfect for running on tarmac. It's not comfortable, so I'm not going to be sad that it's not good to cruise around town. I just want to go as fast as possible in a straight line on this thing. So I actually have a question, and that question is, how do you think we should do it? Do you want to see lithium powered? Do you want to see brushless? Do you want to see something else weird? Let me know what you think, because this is going to be one of my next scooter projects coming up soon. I'm going to take this, we're going to throw some parts at it and see how fast we can go in a straight line. It's going to be terrible in the suburbs. You're not going to want to ride it on the footpath, but that's not the point. This is just a high-speed vehicle for doing ridiculous things, and hopefully I won't get hurt doing it. But tell me what you think. Tell me what you want to see on this, and stay tuned, because I'll have parts for this rolling in soon, and we're going to get crazy. Till next time, TK out.